Okay, we're going to look at correlation coefficient. Okay, so I'm going to introduce it here real quick with a couple little drawings. So we've made scatter plots, right? Oops, that's not the right color. So we've made scatter plots right now looking like this, and we put data points on them. Okay, and right now we've looked at them and we've applied an opinion on them. Okay, and we've labeled this as let's say moderate and positive. Okay, so which is good. I can make a quick judgment on it, but we need to be a little bit more exact than that. Okay, so what that is we are going to use what's called the correlation coefficient. Okay, and that's your R value. What's going to be referred to as an R value. And this is going to put a numerical value on a weak, a moderate, and a strong relation between the values. Okay, so it's going to put a number value on it. Where's my numbers? Okay. So in this case, a correlation coefficient for a positive graph or positive relation is anywhere between 0 and 1. If it's a negative graph, so if it's going down, it goes from 0 to -1. Okay, and the number is going to give you here hold for both, as in a strong relation gives you an R value. These are R values between 0.6 and 1. This would also mean, let me redo this. Where's my purple? My purple's gone for some reason. So this is for negative 0 to 1. For a -1, it's going to be from negative 0.6 to -1. So they flip on either side. For a moderate, we're looking from anywhere from 0.4 to 0.6. And that would also mean for this one, it's negative 0.6 to negative 0.4. For weak, we're at 0.2 to 0.4, which would be negative 0.2 to negative 0.4. And lastly, no correlation, which of course I didn't put any room here. No correlation is anywhere from 0 to 0.2. And for negative, it would be the same. But generally, anywhere from -1 all the way to 1. Okay, but these are the numbers here that you want to memorize up here. These are your ranges that you need to pay attention to. Okay, so what we're going to do here is we're taking what looks like this, and then we're going to use Desmos on your phone, and we're going to apply one of these numbers to it so we can look at it and say, oh, it looks like this. But depending on the scale going up and down, it may or may be strong, it may be weak, or anything like those lines. But we're actually going to put a numerical value on strong and weak. Okay, let me go through this note here. So correlation coefficient determines the strength and direction of linear relation, right? We said that up and down, moderate 0.4 to 0.6, strong is going to be above that. The one thing here is your R squared value, okay? So your R squared value, what's it called? Coefficient of determination. That's your coefficient of determination. So that's telling you the effect of changing X changes Y. Okay? So this also goes between, has the same ratio as above. The exact same strong would be 0.6 to 1. Okay? Moderate 0.4 to 0.6. Okay? Has the exact same numbers along here. So if I had an R squared value of 0.8, that means there's a strong change. So when I change X, there's going to be a strong change in Y. Okay, so there's more of a relation between I change one, the other one changes. Okay, so like if we were doing training, and we did a graph here of, we did a scatter plot, and our R value was like 0.9, and our R squared value was 0.81. That would mean, in this case, there's a strong relationship. Let's say this was like talent and training hours. That means there's a strong relationship to the more training hours I have, the more talented I get, right? And this here is telling you, if I change the X, there's going to be a strong change in my Y value. As in, if I move up in hours, that means there's going to be a strong change up. Now, if I had something that was more spread out, let me use a different color. Let's use black. Let's say I had something that was much more spread out, and I had an R squared value of like 0.4, that means there's a moderate change. You can kind of see it here, as in there's not a direct change when I change one, the other doesn't change that much. It may not change as much. It's a moderate change. Where the purple going through the middle here, my purple going through the middle, there's a strong change. Whenever I change the X, the Y is changing. Whenever I change the X, the Y is changing. So that's our R squared value. And if we have an R squared value, we can go to R by taking the square root of our R squared value. Okay. R value is only for linear relations. You can't have it if there's a curve involved. Okay. Relative strength, blah, blah, blah. Right. So I'm going to walk you through how to use Desmos to find all this. So what you would do, you'd have your data and you want to see, you can plot it, you can make a line of best fit, but you actually want to know how strong the data is in relation. And what you can do is do the R and R squared value to give you a numerical value on the strength of the data. So the way you do this is we're going to use Desmos to do this. And these are the two formulas you're going to use. Oops. Formula 1 is right here. And formula 2 is right here. Okay. There is a spot on your notes to self. Boom, boom, boom. Notes to self. There's a spot right here for your formulas. A spot right here for your R values. Your R squared value definitions there and there. So if you might want to pause the screen right now and copy this down so you know what's going on here. And this is where I said -1 to -0.6 is this. These are the positive, and this is for a negative line. Okay, so it's the same for a positive and negative. So if you want to pause it there and write down these, then you can rejoin me on the other side. I'm gonna have a sip of my drink. So using Desmos. So if I go here, do this on your phone with me. Desmos.com is where you're going. Okay. then say open graphing calculator. And you get something that looks like this. Now on yours, I don't think you have all this right away. This might be at the bottom. If you want to, hit the plus button, hit table, and it'll bring up a table of values. And that's where we're going to input these numbers here. All right, so I'm going to write these down. We're going to input these numbers here. So it's 1, 3, 5, 7, 9, 2, 4, 4. All right, so we're going to go Desmos. And we're going to input these numbers. So you got to go to the plus, pick table of values. Then we're going to input these numbers here. So it's 1, 2, 3, 4, 5, 4, 7, and 8, and 9, and 3. Oops. And boom, we have our little scatter plot here. Now you can look at it and say, oh, what is it? We know it's kind of positive because we're kind of going up. And you'd probably say it's between moderate and weak, but you don't know. We only have a few points. So now we are going to do our linear regression. So if you go to your linear regression formula that I got you right in Desmos, it is y1, as in it's referring, you're telling Desmos to look at the y1 numbers. Then we're going to put in that little swirly line, which is the tilde. And that is, I don't know where it is on your calculator, but you're going to have to go to, like when you're here, you have something that looks like this. Then you have to go to AB maybe. And it's right down here. See where my mouse is right there. Okay. Then we're going to go MX1 plus B. And it's going to make a line of best fit for us. Okay. And with that line of best fit, it's going to give us an R value and an R squared value. Okay. And that's our correlation coefficient, which is our R value right here. Oops. Right there's our R value. And the R squared value is our correlation of determination. So how much is changing X affects Y. So in this case, it's 416 here. So 416. And then the other number is 1731. 0.1731. And we write down this equation of a line 2, y equals, if you look, it gives us here our m values 0.3 and 2.7. 0.3x plus 2.7. If we remember back to grade 9 math and grade 10, that's your slope, how fast it goes up and down, and that's our start or y-intercept. But let's look over here now for me. So the question is, what does this tell us? Well, first of all, the relationship is a positive relationship, so that's a positive number. Now it's 0.4, so that's in our moderate range. So we would say it's a positive moderate relation. And then you say our determination here, how much does affect changing X change Y? Well, it's very weak since it's at, if I round that to 0.2. Okay, so when I change X, Y doesn't change that much. It's a very weak relationship in terms of how much does X affect Y. But that's how we find our correlation coefficient and our coefficient of determination. We're defining the relationships. So let's do another one. So here I grew a plant and I tracked its height versus how many days. And I wrote it in a very weird fashion here. So now I will call, I got to write this down on a separate piece of paper. 0, 1, 10, 12, 8, 7, 13, 14, 9, 10, 11, 11. Dog, get out of my way. My dog is bugging me and trying to get pet. Now she's leaning on me. Sit. So I got to pet her for 30 seconds, then she'll be better. So now we go back to Desmos. Now a little trick here. See where it says X1 and Y1 up here? It says Y1 and X1 right there. So that's referring to that table. If I add another table, I click here and I click add, and I go table, these are X2 and X1. So when I go to write in my formula next time, I have to write Y2. It tells me to look here. If I told it to look at Y1, it'd look up here. A little trick, I can tap these here, and those lines will disappear. Oops, that line will disappear. Or I can hold it. Oops. I can hold it. Once I usually hold it, I can change the color. But I'm going to get rid of those ones. I'm going to type in my numbers here. If you follow typing as long as mine too, 10, 12, 8, 7, 13, 14, 9, 10, 11, 11, 14, 13. So there I made my scatter plot right here. Now I want to do my linear regression. Now remember, I'm using X2 and Y2. So I go to write this in, it's going to be Y2 tilde MX2, oops, plus B. That's going to make a line of best fit for my data. So what's my numbers this time? My R value is 96, 0.96, 0.97. This is 0.94. So let's go back here. So 0.97, 0.94. So here we have a very strong coefficient correlation. So there's a very good connection between the data, the age of the plant, and the height of my plant. And as I change X, or as I change my days, there's a strong change in my height. So as the days go up, there's a strong attachment to the height of my plant. Okay? So now here, we could also do a curve. And I gave you the curve formula, which was y1 tilde ax1 squared plus bx plus c. That's for a parabola. Okay? We could do exponential as well. I forget the formula for exponential as well, but you can also do an exponential one. So, in this case, same steps, but just your formula is going to be a little bit different. And the formula you should have wrote in your notes to self. So we have, let me write down my numbers. 0, 0, 1, 1, 2, 4, 3, 9, 4, 15, 5, 24. We can go back to Desmos. Now, make my life simpler. I'm going to get rid of this one. I'm going to press the X, get rid of that one. I'm going to get rid of everything I wrote before. I'm going to go add a table. Then I'm 0, 0, 1, 1, 2, 4, 3, 9, 4, 15, 5, and 24. So here you can see, by looking at it, it looks more like a curve. Right? Now you could do this one, do the first one, the linear one. And you look at it and say, is that really going to work? Well, maybe our value is 96 and R squared is 92. Okay. But you say it kind of looks like a curve, so you could actually write in the curve one as well. So y1 diddle a x1 squared. Now when you do squared, use the hat, which is on top of the 6. Or on your thing, you should be able to add a square. If I'm using this, there's a square button right there. bx1 plus c. Now here, you can look, there's no r value, but look at the r squared value. It's pretty much bang on. It's even stronger than the r squared value here. So you can see in terms of a curve regression, a parabolic regression, it's almost perfectly aligned where if I change x, we're changing y. So sometimes it's beneficial to look at, is it a curve instead of a line? Right? So to review, as we work through this, we're looking at correlation coefficient to find the numerical value of the relation. Determine the correlation between the variables. So we're looking at strength and direction. When we do our correlation coefficient using Desmos, it gives us a number for our r value and our r squared value, which allows us to, with confidence, label it as strong, moderate, weak, or no relation. Before, when we were looking at it, it would look good, but we just don't know. Right? We just don't know exactly. But here we go with the r squared value. Sorry, it's percent. So in this term, like 44% of the variation in y is due to change in x. Okay? So on this one here, only 17% of the change in y is due to change in x. Or here, 94% of the change in y is due to the change in x. So it still follows strong, weak along those lines. So as you work through your practice, where's our practice? Which is already in your notebooks. Where's Albie? Boom. We are going to go into lesson 3 practice. You're going to work through these using your r squared value and such. Oh, one thing I could show you. Let's go back to Desmos. And let's do a little, let's use, oh, I erased it. Where's my plant stuff? So we're going to go back to our plant. The one where we had a plant. 0, 1, 10, 12, 8, 7, 13, 14, 9, 10, 11, 11, 14, and 13. All right. So there's the numbers for our plant. I do my a regression. Now, we can use this formula, 0.94 and 1. Let me go back here. This one here was y equals 0.94x. That was my m value. Remember how we wrote in y1 tittle mx plus b. So we're just replacing this number and this number. What's in right here, our m value and our b value. Plus 1. Now it may make more sense as in height equals 0.94 per day plus 1. And we can use this formula for predictions. So I could say, okay, how big is our plant going to be after 5 days? Right? Therefore, we're going to plug in for the d value. So it'd be height equals 0.94 times 5 plus 1. Now if we plug that in our calculator, we're going to get 5.7. So we can make a prediction that on the 5th day, our plant is going to be so tall, at 5.7 tall. But I have to say, okay, when's the plant going to be 10 centimeters high? And then I just do the opposite. This is going to go in for our h value. So 10 equals 0.94 plus 1. That was D for days. Move that over. 10 minus 1 equals 0.94. D. 9 equals 0.94. D. Move that over. Becomes a divide. 9 divided by 0.94 equals D. So 9 divided by 0.94. So at 9.6 days, that's when our plant should be 10 centimeters high. Okay? So that's how we could also use it for predictions, is pull the formula off of Desmos and go from there. And just so you're wondering, yes, on your test, I will let you use your phone to use Desmos. Okay? And that should be everything for today. You have your practice in your folder for you to work on, and I will see you tomorrow.